All right, last set of notes for the chapter 5-6B. Please notice you have a quiz Thursday, and your test is next week, and it's right now set for Wednesday of next week. Okay? I know there's some sections we haven't done, but those sections are the same rules. It's just another way of looking at the shapes, so we might not do those. All right, trapezoids. By looking at the shape, what do you think makes a trapezoid different than a parallelogram? Only one pair of sides that are what? Parallel. Good. It only has one pair. This pair of sides right here is parallel to this pair, or this side is parallel to this side. Those parallel sides are called the bases. Base 1 and base 2. Some of you might recognize that from an area formula you've done in the past. Okay, these that are not parallel to each other are called legs. This is a leg, and this is a leg. Base angles are a pair of angles that touch the same base. So A and B are base angles. What's another pair of base angles? They touch the other base.
D and C.
D and C. Good. Sometimes those are congruent, sometimes they're not. It depends on the trapezoid. So a trapezoid is a quadrilateral with exactly one pair of parallel sides. If the other pair of sides were parallel, then it would be a parallelogram and not a trapezoid. Questions on that?
Yeah.
All right. Here's something you should recognize. We did it with triangles. We're going to do it for trapezoids as well. It's almost the same except that a trapezoid has two bases. A midsegment is a segment that joins or connects the midpoints of the legs. If this is parallel to this, then those are the two bases. On this picture, the midpoint is right here, and it cuts that segment in half. That leg gets cut in half. On this one right here, this is the midpoint, and it cuts this leg into two equal pieces, and the segment, or I'm sorry, the mid segment is the line that joins them right here. Okay. The rule is, just like on triangles, the mid segment is parallel, but this time it's parallel to both sides, or both bases of the trapezoid, and its length is half as long as the sum of the bases. So it's parallel, and it's half as long, but this time there are two bases to worry about, to both bases. I'm going to give you a formula again that you can just cross multiply. So in this example here, let's draw the mid segment from here over to here. And, sorry, if I sneeze, don't let me scare you. All right, so name for me three parallel lines right here. Oh, wait, let me call this EF. Name for me three parallel lines. AB is parallel to DC, which is also parallel to EF. Okay, whenever you have a mid segment, you are parallel also to those two bases. Now this formula I'm going to give you next is extremely important. It's with letters. You'll eventually do it just with numbers, but this segment EF, the mid segment, the one that's in the middle, does not get divided by 2. That's the answer. It's equal to the other two bases divided by 2. What are my two bases? AB, and yeah, just like that other one, except the problem, the difference with the other one was that it had only one base. This one has two bases. Okay? So, sometimes I'm just going to write bases divided by 2. You just have to remember that it has to be both of them. All right, so now let's look at isosceles. Well, go ahead and turn to your charts and let's fill this one in before we do the isosceles. So, what makes a trapezoid a trapezoid? One pair, parallel sides. Hey, you guys, are you focused over there? We're in the middle of notes. Get these notes till you're good, and then you can talk while you're doing independent work. Trapezoid has, write this down, consecutive angles are supplementary. And that's not a new rule. Think about it. If these two lines are parallel right here, if this line is parallel to this line, what kind of angles do you have right here? This is a transversal. Are these same side or alternate? Right here. Same sides are supplementary. Good. So that's all they're saying. Two angles on the same leg are inside the parallel line. Same sides are supplementary. So that's not a new rule. It's just a reminder. And then the last one is that anytime you have a trapezoid, whether it be isosceles or not, you have a mid-segment that is parallel to the bases and half of the bases. This is bases right there. Okay, that's for all trapezoids. But then there's a special kind of trapezoid as well. Anybody still ready? All right, then let's look at this kind, isosceles, just like triangles. What do you think an isosceles trapezoid is going to have? How many congruent sides? Two. Isosceles means at least two congruent. So, an isosceles triangle has two congruent sides, and isosceles trapezoid has two congruent sides. Those are called the legs. So, if this is a trapezoid with lines parallel here, then these two equal segments would make it isosceles. Whenever anything is isosceles, it has a couple more things that are special about it, a couple more things that are true. If a trapezoid is isosceles, then each pair of base angles are congruent. Base angles are the angles on the same base. Thank you. I think I'm going to let them leave a message. I was trying to decide how I should run it. All right, so if this is a trapezoid, because the lines are parallel, and if these legs are congruent, then the rule is that the angles on the same base, where the parallel mark is, that makes the bases, then these two angles are equal to each other automatically. Only when it's isosceles though. Only if these two sides match can these two angles match. And name for me another pair of congruent angles along this base. D is congruent to C. Okay? That's only when it's isosceles. But these two angles right here would add up to what? 180 always, whether it's isosceles or not. All right, this is just the converse. If a trapezoid has one pair of congruent base angles, then the trapezoid is isosceles. Theorem. A trapezoid is isosceles if its diagonals are congruent. Now, I know you recognize that. Other places have diagonals that are congruent. But since this isn't a part of the parallelogram family, it's listed separately. If a trapezoid has congruent sides and the bases are parallel, only in isosceles triangles, you're allowed to say that the two diagonals, AC and BD, are equal to each other. They are not cut in half. They're not bisected. It's not a parallelogram. But only in isosceles triangles, you can say that AC is congruent to BD. So if you ever see that in a problem or in a picture, you make them equal to each other and then solve for the variable. Alright, now as you can see, there's lots of other things here. There's alternate interior angles right here. There are vertical angles. There are even some congruent triangles. There's lots of other things that happen, but these are the three main rules that they write out for you. Anyone still writing? Let's finish up that chart. The isosceles trapezoid, it's a trapezoid with two congruent legs. The legs are the ones that do not have parallel markings. Parallel marked legs are the bases. Sorry, the parallel marked sides are the bases. The legs are the ones that are not parallel. Okay, what else do we know about an isosceles trapezoid? What about the angles? What does it say specifically there? The base angles are congruent, yep. These two along the same base are equal, and these two along the same base are equal to each other as well. What's the rule about the diagonals? Congruent, but only when it's isosceles. That's the only time. So you have congruent diagonals whenever you have an isosceles triangle or a rectangle, which also makes a square. And what are the two times that you have perpendicular diagonals? Two cases. Look on your chart, right? Rhombus, yes, and one other. Look on your chart. You don't have to have it memorized. Kite. Good. A rhombus and a kite have perpendicular diagonals. Which two shapes have congruent diagonals? Look on your chart. Congruent diagonals. Rectangle and no congruent diagonals. Yes, a square because that's a type of rhombus. Oh, sorry, type of rectangle, and then the isosceles trapezoid. Yeah, the congruent diagonals right there. Okay. So we're going to spend some time tomorrow where I'm going to give you some properties, give you some shapes, and you're going to pick which shape it is. We're going to practice a lot of that before the test. But tomorrow your quiz is going to be on what your homework problems have been, solving for x and finding like the missing angle there. Okay, so like the homework since Monday. So we'll make sure you've had all those answers before you take a quiz on it. All right, so turn the page and let's, there's no true falses on that one, is there? No. Let's try a couple down the sides. Find all the missing angles. I noticed that these lines are parallel, which makes it a trapezoid. So I automatically know that same side angles on the legs are going to be supplementary. So what's angle 3 have to be? Right here, between parallel lines, you always have supplementary angles. So angle 3 would equal what? 120, 122. Good. 122. Because you take 180 minus 58, and that's the case always between parallel lines when they're on the same side of the transversal. Okay, did you notice that these two legs are congruent? So that means that base angles are congruent. So you look at the top base angles. These two angles are base angles. They're on the same base, that parallel line right there. So what's angle 1 going to be? And what's angle 2 going to be? You know, trapezoids don't have to be laying flat. They can be up and down like this. You just look at where the parallel lines are. Okay, so take a second now, and I'll do one more with you. Which one do you think is easiest to find? Angle 1, what would that be? 109. Good. All right, how would you find angle 3? Subtract from 180. Good. Is that 81? No, 71. Correct me if I'm wrong. And what's angle 2 going to be? 71. Take 20 seconds right now and find an answer number 3. Now for isosceles, you know that at least two pairs of angles are going to match. So what did you get for angle 1? Good. 180 minus 44. What did you get for angle 2? 136. And for angle 3? Any questions on those? Okay, you'll probably see something like that on your quiz. Look at the next row down. Now we're not just talking about angles anymore. Now we're talking about mid-segments. And write this down with me right now. Write it at least once. Mid-segment, I'm going to abbreviate, say mid-segment equals, the middle segment means middle means half, right? So it equals half of something else. It equals the two bases, plural, divided by 2. You have to have 2 of the bases, and then you divide by 2. If you set it up that way, then it will be easier for you every time. If you try to do it in your head, it will be confusing. So in this picture, find for me the mid-segment. Is it 10, 2x, or 3x minus 4? 2x. So in place of mid-segment, write 2x. I don't want you to think of like the longer one, the shorter one, whatever. Just think the middle one goes here. And then it equals the bases divided by 2. Name for me, or give me the numbers of the two bases. 10, 3x minus 4. Some of you will do that in your head, but I'll just write it out. 10 plus 3x minus 4. The two bases, and then divided by 2. At this point, you use whatever way you think best from algebra. I will probably always cross multiply just to be consistent. So, what I have is 2x times 2, that would be 4x, equals, can I go ahead and combine my like terms right here? 3x plus what? 6. Positive 10 and negative 4. Minus 3x from both sides, and you get x equals 6. Okay, so the only time that's going to get confusing is if you forget to take the mid-segment on the left and put the two bases on the right divided by 2. Everything else is just solving, just algebra. And I'm going to go through the rest of them with you, and then you're going to try the bottom ones on your own. Oh, I didn't go back and read the directions, did I? Thank you. Okay, find GH. Someone asked and someone told. So Naya told me, who asked? All right, I'll count that too. So GH. If x is 6, what's GH? 12. Equals 12. All right, let me do these with you so that you can try the bottom ones on your own, but I want to make sure you have enough practice. Number 5, mid-segment first. What's the mid-segment? 4. Good. The middle one is the mid-segment. So always put that alone. 4x plus 1. And it equals the two bases divided by 2. If you combine your like terms in your head right here, that's fine. What are my two bases? 10 plus what? Okay. And it's not always the top and bottom necessarily, but it's always the two that are parallel to each other. All right, so, and then it's divided by 2. So I'm going to cross multiply. 2 times 4x minus 1. Yes. You can find other ways. You can multiply both sides by 2. You could sometimes, if they're all even numbers, you can cut them all in half, divide by 2. There are other ways. I'm always going to cross multiply so that it's always consistent. But there are other ways. That becomes 8x what? 8x plus what? 2. Good. Don't forget to distribute. 4x times 2 and 1 times 2. And that equals 6x plus what? 8. 10 and negative 2 makes 8. Minus 6x on both sides. And minus 2 on both sides. We get 2x equals 6 and x equals 3. How'd you get what? Go back and plug it into GH. Good. So x is 3. 4 times 3 is 12. 12 plus 1 is 13. Okay, before I have you try these on your own, do numbers or set up number 6 right now, and then let me make sure you have it right before you finish it. Think about what the mid-segment is, make that one stand alone, and then add the 2 bases and divide by 2. Okay, so before you continue trying to solve it, let's make sure you get set up right. What's the mid-segment? 3x minus 6. That's the one that goes first and it stands alone. That equals, what are the 2 bases? 2x minus 1 plus 25 divided by 2. If you end up with even numbers and you want to divide them all by 2, you can divide it by 2. So that's going to be, go ahead and solve that. Put that over 1 and cross multiply. If your homework, do the bottom of that. This is not free time. Do number 7 through 12. And number 9 is a little bit different, but look at your chart as you think about those rules. Okay, think about which rule would apply to number 9. Finish the page.